Hello students. So now I will explain how to draw a polar graph or polar chart uh, from these recorded readings. Now last day in our experiment we have done a study of radiation pattern of a folded dipole antenna. So there we have recorded angle versus receiving current. So I have tabulated all the data here. So these are the angles with 10-degree deviation or 10-degree increment, and these are my receiving current. Now we have also two calculated columns there. So to do that calculation we need maximum receiving current. So go through all the receiving current and you find that this is your maximum receiving current reading. So for this experiment we have 89.4 is our maximum receiving current. So we call this Imax. Now what we have to do, we have to apply this formula for I0. So formula is I by Imax. For every value of I divided that value with Imax. Imax means 89.4. Now for every case you get value of I0. So here you have all these calculated readings. So what we are doing here, we are just normalizing this receiving current value in this column. So I0 is the normalized value. Now after that we do this calculation. The calculation is dV is equal to 20 log I0. So this is our dV readings. Now our job is to plot angle versus dV. So angle versus dV. So angle is already there and dV we have calculated. To plot this data angle versus dV, we need a polar plot. Polar plot I have already provided in your classroom in syllabus and other document section. So go there and download the polar plot. Blank polar plot is there. So you can download it, print it, and then you do the polar plot. So how we do that? So polar plot actually looks like this. So this is a blank polar plot. Now before we plot, we can see these are the angle divisions, say 0 degree, 10 degree, 20 degree, 30 degree. So these are polar readings. We also have a linear reading here. So these are the scale, this is the scale. In every straight line, I have to put the dV reading here. So angle reading is this and dV reading I have to put here. So before I just mark every dV reading here, I have to scale this polar plot properly. So I have to scale this linear line. So how we do that? So in our dV column, we go through all the values and find out maximum and minimum value. So in my case here, I have already marked it with green and say red. So green is my maximum value and this red colored is the minimum value. So you also calculate all the values and go through all the values. So there you find that 0 is your maximum value and as every value is in negative, so minus 33.92 is the lowest value. So this is my highest and this is my lowest value. So write down this value first. So highest high is 0 and say low is minus 33.92 dB. Okay. Now as if you observe closely, you find that this is a 5 division polar plot. So how many divisions are there? 1, 2, 3, 4 and 5. So as we have 5 divisions there, so I just round up this value to a number that is divided by 5. So the range will be the whatever you get, whatever your readings is, should be within this range. So I take some value that is lower than this value and it should be divided by 5. So nearest value of 33.92 divided by 5 value is minus 35. So I set this range, lowest and highest range, such that all the readings should be within this range. So all my readings should be within 0 and minus 35. So this is my minimum range and this is my maximum range value. Now as I have scaled it, so this is highest and this is lowest range. So I just make a difference. The difference is 35 or minus 35. Okay. Now as we have 5 divisions, so divide 35 by 5, you get minus 7. So 7 is your division. Now scale it. So I start from 0 is the highest value, 0 dB, then minus 7 dB, then minus 14 dB, then minus 21, then minus 28, and this is minus 35. So now we understand, if we have a dB reading, so you go through all the dB readings, then you find the highest and lowest value, then you set your range properly. You set your range such that all the readings should be within that range. Then difference the highest and lowest value, divided it by 5 as it is a 5 division graph. Then you get each division. So put that division accordingly, then you have scaled your graph. Now the thing is, as I have scaled my graph, now I can put all the values in this graph. So start from 0 degree. So 0 degree I have minus 1.54. So how can I put it there? So minus 1.54 is between 0 and minus 7. So for example, at middle section it is minus 3.5. Now if you go to the midpoint of this, it will be more or less than 1. More than 1.5. So the reading is minus 1.5. I can put my mark here. Now remember that you don't need to write minus 3.5. Okay, you just imagine that this is the midpoint and you put your mark at proper position. So this is your first mark. Now at 10 degree the reading is minus 2.27. So minus 2.27 at 10 degree, so division is like this, 2.27, as we know this is minus 3.5. Say I don't write it. So this is the midpoint, this is minus 3.5. So 2.5 is between 0 and minus 3.5. So somewhere like this. You don't have to be exactly the point. You can make some assumption and you put accordingly. It will solve the purpose for this graph. Now again at 20-degree division, just erase this. Okay. Now at 20-degree division, the reading is minus 3.22. So 3.22, again 3.5 is there, and 3.22, say I put a little before midpoint. Okay, so these are my marks. So if you observe that the power is decreasing slowly as angle is increasing. So then minus 5.33. So 5.33. So this is 3.5 in the mid, and this is 7. So it is between 3, say 4, 5, 3. You have to assume that 5 is here. This is between 3 and minus 3 and minus 7, minus 3.5 and minus 7. So it is done. Now at 40-degree we have minus 6.79. It is close to minus 7. 6.79 is close to minus 7, so I put it here. Then at 50-degree we have 9.84. So 9.84 is somewhere between minus 7 to minus 14. So between minus 7 to minus 14, so 7, 8, 9, 10 is here. So minus 7 is this line, this red line is minus 7, and this red line is minus 14. So somewhere between these two red lines, this midpoint is minus 7, 8, 9, 10. So I put a little above of this line, midpoint, so that is minus 9 point something. What was the value? 9.84. It's near about 10. Now at 60-degree, the value is minus 13.92. So 60-degree is the value is 13.92. So this red line is minus 14 dB. So 13.92 is just above that line. It's 13.92. It's almost 14. At 70-degree, our value is minus 16.88, almost 17. So 17 is 14, 15, 16, 17. 17.5 is the midpoint of minus 14 and minus 21. So you can put here. The value was 16.88. It is almost 17. So you can put your value here. Now at 80-degree, it is minus 15.92, almost 16. So now 80-degree. So at the midpoint it is 14, 15, 16, 17.5. So if we draw a circle here, it will be minus 17.5 dV circle. So before that we can put our reading, that is minus 15.92. So 15.92 is between 14 and 17. So you can put your reading, say exactly here. It is before 17. So I just put my reading before 17. So that is 15. Then at 90-degree, minus 11.17. So at 90-degree, 11.17, 11, where is 11? So it is between minus 7 and minus 14. So it is between this red line and this red line. Now the midpoint of minus 7 and minus 14 is minus 7, 8, 9, 10. So this midpoint is minus 10.5. Now our reading is 11.17. So it is after 10. So 11.17 you can put here. Okay, and then 100 degree. 100 degrees minus 8.05. So 8.05 again 7. This circle is for minus 7, and I can easily put minus 8 point something. It was minus 8.05 at 100 degree. So I just put my reading. This red line is for minus 7. I just put my reading after that. So this is for minus 8 point something. At 110 degree, reading is minus 5.49. So 5.49 is again between 0 and minus 7. So this line is for 0 dB and this line is for minus 7. This is for minus 3.5. So minus 5 will be, say, here. Okay, and 120 degree. Now 120 degree, it is minus 3.57. So 3.57, it is again 3.5 is exactly at the midpoint, so I can put here 3.57. Then 130 degree minus 2.04. So 2.04, say this is the midpoint, that is minus 3.5, and 2.04 is somewhere between 0 and minus 3. So I put that reading here. Now at minus 140 degree, 140 degree, I have reading 0.92. See, this 0.92 is almost equal to 1. So I put this reading is near to 0. Near to 0, but it is almost equal to 1. So a little bit difference from the 0 dB red line. Then at 150 degree, the reading is minus 0.27. So again, a very tiny or very little gap between this red line, 0 dB red line, and our reading. It's almost at 0. At minus 160 degree, it is 0. So 160 degree, put your reading here on the 0 dB red line. Now, if you observe very carefully that these points are following a pattern. So if we join these points, our pattern will be created. So that is the radiation pattern of the antenna. So I have to complete the graph first, then I join all these dots and get my radiation pattern. So to do that, I just put all these points one by one and complete the graph. So 0.06. Okay, so finally I have plotted all the points on this polar graph. Now I have to join all the points with, say, if I join all the points very smoothly, so you can see that a radiation pattern curve is formed. So this is just join all the point properly, and so as I have joined all the points, now this this pattern is called radiation pattern. So actually it looks like this 8, numeric 8. So this is the radiation pattern of the antenna we have connected. Our antenna was folded dipole antenna. So I just write a dipole folded dipole antenna. So whatever antenna you are experimenting with, just write the name of the antenna here so that we can understand that uh, the pattern is for that particular antenna. Now, remember that you don't have to write all these things. You just please don't write all these things in your polar graph. It is just shown for how we scale the graph. So you can scale the graph in rough and then just put that scaling marks accordingly. Just scale the graph in a rough paper or in somewhere in rough, and then you put it on your polar graph. So this is actually should not be here. So please don't put anything on the polar graph, just put your scaling on graph and write down the antenna name under here. In your format, I have also provided the name and university roll number, so you can write down your name and university roll number in the polar graph. It is important. Everyone have to write their name and university roll number, and then you can take a snapshot or and then you can make the PDF file. So that for every polar graph I can see the name is written here and the roll number is written here. Now, after we have constructed the radiation pattern, now we have to do one thing more, that is 3 dB beam width. So calculation of the 3 dB beam width we have to. So to calculate the 3 dB beam width, what we have to do, just go to the maximum power. So where we have the maximum power, so we have maximum power at 360 degree. Sorry, 160 degree. So at 160 degree we have 0 dB. So that was our maximum power. Now come to 160 degree and from here go 3 dB down. So how we know 3 dB down? Just remember that this outside circle is for 0 dB and the second this red circle is for minus 7 dB. So between that we have a minus 3.5 dB division. So near to that is 3 dB division. So this is your 3 dB down dB line. Okay, so I just put a mark here, and what we have to do, you just take the radius measurement from center to this 3 dB down point. So first what we have done, we just go to the table and find out where was our maximum reading. So maximum dB reading was at 160 degree. Now come to your plot at 160 degree. You just go 3 dB down from 0 dB line and mark here. Make this center to the mark point as your radius and just create a curve with compass. So as I am marking it with hand, it is not that much perfect, but you use a compass, So then you get a proper 3 dB line. So this is your radius distance. You don't have to mark it, but I am marking it here so that you can understand. So this is your radius, and this point is 3 dB, minus 3 dB. So at minus 3 dB line, you just make it radius from the maximum power reading. You go 3 dB down, put a mark, make radius from center to that mark, and create a curve. Now that curve will intersect your radiation pattern in two different points. Say this is point 1, this is point 2. Now what I have to do, we just join these two intersection points from center. So I'll join here. Okay. Make it more proper. And this mark. So just use scale, that will be proper. Now measure this angle with protector, and or you can measure it from here. How much degree is there? Say 10, 20, 30, 40, 50, 60, 70, and near about, say, not 70, so just say 10 degree and say 8 degree or something. So 10, 20, 30, 40, 50, 60, 70 and 78, says 78 degree. You can also measure it with a protector, or you can calculate it from the division, polar division. Now this 78 is your 3 dB beam width. So you can write it here. So 3 dB beam width is 78 degree. So you just mark it 78 degree or something, whatever angle you get. So that is your 3 dB beam width. You don't have to write anything, just join these two intersection points and write down the angles. Okay. So this is your 3 dB beam width. So that's how radiation pattern of folded dipole antenna is constructed. So this is our radiation pattern. We have also calculated the 3 dB beam width. In the same way, you can also calculate the 3 dB beam width in the other half, that is this portion also. So we have calculated for this lobe, back lobe it is, and this is front lobe. Front lobe, you can also calculate 3 dB beam width in front lobe also. So again the same thing, you just down from this 0 dB line. So this is 3 dB here, and make it center. This is your radius, and create a curve. So that curve will intersecting this radiation pattern graph or radiation pattern in two different points. This is 2 point, and you join these 2 point to center. Okay, and then you measure this internal angle. Now you just write down the angle here, and that is your 3 dB beam width. So do that for every radiation pattern experiment of antenna. So the antenna graph is provided in the classroom. So download that antenna polar plot, and then print it, and then by hand you make this graph, then scan it or just take a photograph, and with the manual or say whatever you have written in the experiment, just make a PDF file with all that and upload it in the assignment section. So that's all. Thank you. Just watch this video carefully, and you can, I think you can do the polar plot properly. So if you have any doubt, just ask in the comment section of this video. Thank you.